The truth tables we are going to look at in this video contain only one logical connector or negation. The next video will take a look at truth tables for more complex statements. Example 1 defines the following propositions. R, you paid your rent this month. E, you paid your electric bill this month. We are going to create truth tables for the given propositions. Our first proposition says, you did not pay your electric bill this month. This proposition is the negation of the given proposition E. We use the tilde symbol to represent negation. Now, let's think about how this will look in our truth table. The truth table helps to organize the truth values of statements. We start our truth table by identifying our original statements and their possible truth values. For statement E, the only possibilities are that you either paid the bill or you didn't. So we can write true and false as our options in the truth table. In the next column, we will write the possible truth values for the new preposition, not E, which is the negation of E. If E is true, the negation of E would be false. And if E is false, the negation of E would be true. This completes our truth table. The next proposition is, you paid your rent and your electric bill this month. We start by using symbols to represent this proposition. You paid your rent is represented by R, and you paid your electric bill is represented by E. We will write these in the first two columns of the truth table. This proposition uses the logical connector AND, which is represented by the wedge symbol. We will write our proposition in symbols in the rightmost column. Next, we will fill in all of the possible truth values for the given proposition, such as you paid your rent and electric bill, you paid your rent but not your electric bill, you did not pay your rent but you paid the electric bill, and finally, you did not pay your rent or your electric bill. Once we have all of the possible truth values for the individual statements, we can determine the possible truth values for the overall statement, you paid your rent and your electric bill. For an AND proposition to be true, both statements must be true. The rest of the combinations will be false. What about the proposition, you paid your rent or your electric bill this month? This proposition uses statements R and E again, but this time with the logical connector OR, which is represented by the V symbol. We will set up the first two columns of our truth table with the possible truth values for R and E. Notice that this is the same as the setup for our previous truth table. For an OR proposition to be true, at least one statement must be true. Another way to think of this is that an OR proposition is only false when both statements are false. This means that the last combination is false and the rest are true. For our last truth table, we have the proposition, if you post that photo to Facebook, you'll lose your job. I'll start by representing you post that photo to Facebook with the letter P, and you'll lose your job with the letter Q, and place these at the top of the first two columns of our truth table. If-then statements are represented with an arrow pointing to the right. We write this representation at the top of the last column. Our proposition, if you post that photo to Facebook, you'll lose your job, is essentially saying, if you post the photo to Facebook, you'll lose your job. However, if you don't post the photo to Facebook, then you may or may not lose your job. I don't know. By now, you may have picked up on a pattern for completing the first two columns of the truth table. The first column is true, true, false, false, and the second column alternates between true and false. This first row has true for you posting the photo and true for you losing your job. This means the proposition is true. The second row has true for you posting the photo, but false for you losing your job. This means the proposition is false. For the last two rows, you didn't post the photo. Since the proposition does not say what will happen if you don't post the photo, the proposition is true for both of them.